Welcome back to Introduction to C++. My name is Kate Gregory, and I'm introducing you to the most popular general-purpose programming language, C++. In this module, you'll learn about templates. Templates in C++ are similar to generics in other languages, but different in some very important ways. When you first get started in C++, you can use templates right from the very beginning. In fact, sometimes you use them without even knowing it. It's less common to write them. I'm going to show you how to write them, but just so we have some simple templates we can use in the demos. Understanding how they work takes the magic factor out of using them. And I want you to know what a powerful technique templates are in C++. Templates are the way that C++ implements genericity. Genericity meaning that you write a piece of code once and it can be used in a variety of contexts. There are generics in C# and in Java, as well as some other languages, different names for the same concept. However, templates are fundamentally different from just about everybody else's implementation. Templates are resolved at compile time, not at runtime. This has some benefits and some drawbacks. The number one benefit is speed. All of the performance hit is taken at compile time. There is zero performance hit at runtime. The compiler actually generates versions of the code for the various types that you're using it with. In languages that do runtime checks, everything happens at runtime. There is a performance cost at runtime. This may give you a little more flexibility. It does, however, slow your application down. A generic-based solution can never be as fast as a template-based solution. The idea is that you write something, maybe it's a class, maybe it's a free function, and it can be used with a variety of different types. Imagine math work like finding the largest something. Could be the largest integer, could be the largest floating point, could be the largest bank account. Finding the average of a whole pile of things, or keeping a collection, an ordinary array, a linked list, a queue, a hash table, a dictionary, every data structure probably that you learned as an undergraduate. You can have a linked list of integers, or a linked list of floating points, or a linked list of bank accounts, or a linked list of employees, and it doesn't really matter. The code about keeping track of the next node and the code for insert and the code for delete is identical regardless of what it is that you keep in there. But these are type-safe collections, meaning that if I have a linked list of employees, I can't add a bank account to that list. Type safety is a huge part of C++. This is how you achieve a type-safe, high-performing collection, and algorithms that work across those collections, sorting them, searching them, that kind of thing. Operator overloads are a big part of how many of these templates are actually implemented, and that's what makes it easy to mix and match so that the same code can be used for, say, integers and bank accounts. I find that other languages tend not to do that. Their general solutions often can only take user-defined types and not the fundamental types. They often rely on the existence of member functions with names like add or compare that are not defined for fundamental types like integers. Using operator overloads gives you compact code and highly readable code. It is also what makes the same templates work for both fundamental types and user-defined types. We've mentioned the standard library a number of times throughout this material, and I'm sure you're already convinced that it's full of rich goodness, even though all we've really seen so far is strings and writing to the screen and reading from the keyboard. The old name of the standard library was the Standard Template Library, or STL, and old school C++ developers like me still often call it STL in casual chit-chat. Yes, I have casual chit-chat about compiler libraries. It's who I am. It's rich in templates, collections, algorithms, and a lot more besides. And as you move forward along your C++ path, you're going to meet a lot of the things in the standard library, and you'll understand them better if you understand templates. By showing you a very simple template. It's right here. This is a free function, and you can declare and define a function all in once as long as the whole thing is before you use it. I could have made a header called utility.h in which I declared this function, and a CPP file in which I implemented it, but especially for templates, we tend to do it all at once in the include, and rather than have a separate file, which the include statement would have just plunked right here, I decided to simply put the contents here. You can see the structure of it. If it wasn't for this first line, it would just look like declaring and defining a function. We have a function called max that returns something called t, and it takes t references. If you're thinking, wait, we covered all the types, int, float, what is t? T is a placeholder, and it's traditional to use the letter T for this placeholder, but you're by no means obliged to. You could use whatever you like. This line here says I'm defining a template, and in my template there will be a placeholder for a class, and despite the word class, you can also put fundamental types like ints and things in here, which I'm going to now refer to for the rest of the time as T. So this says whatever this is a template of. If it's a template of ints, I mean int. If it's a template of person objects, I mean person. That's what this function returns. Its name is max. It takes a T reference, which I'm going to call T1, and another T reference, which I'm going to call T2. And we're using the immediate if, and if T1 is less than T2, we'll return T2, otherwise we'll return T1. So in other words, if it's a tie, we'll return T1. If it's not a tie, we'll return whoever's bigger, using the less than operator. It's hard to imagine a simpler function to write. Once you've really grasped the immediate if, you're done with the difficulty level of this function, but it's really pretty powerful. In fact, I should point out there's a better implementation of max in the standard library. We're only showing you max so that you have something to look at and to understand. I'm going to use it. Change my boundaries a little so you can see this whole line. I'm going to print out max of 33 and 44 is, and then I'm going to call the function passing in 33 and 44. And the compiler's pretty smart. It says, hey, those are integers. You must want the version of max that works with integers. And it'll use that one and return an integer that I can send to cout. Then I set up a couple of strings, and I want to print out the max of them. And again, I just say max of S1, S2. And the compiler says, well, if you want to pass it a pair of strings, you must mean the one that takes strings and returns a string. And I can even work with person objects. Here I'm going to print out p1.getName and p2.getName just so that I have something to put on the screen. But I'm actually determining the max of p1 and p2. And that returns a person. So on a person, I can use the dot operator and call one of its member functions, and that's how I can get somebody's name. So I'm going to run this application and let you see the output. You can see that the max of 33 and 44 is 44. That fits what we know about numbers. That the max of hello and world is world. If you think about sorting, W coming after H in the alphabet, okay, that makes sense. And the max of Kate Gregory and someone else is someone else. Now, in order to test if that's right or not, you have to remember how we defined operator less than for person. Come back and take a look in person. Here's operator less than. We compare their arbitrary numbers. Right, so if one person is less than another, if their arbitrary number is less than the other. And the two arbitrary people I made here, Kate Gregory and someone else had a number of 4, 5, 6, so that's why they were the bigger. This is just kind of intuitive and easy to understand. You're just calling max, max of 2 strings, max of 2 numbers, max of 2 person objects. There is a potential problem. I've got an include here of bankaccount.h. And I'll just open that up and show you. This is a half-written bank account class. We're not going to design or write it. What you need to know about the bank account class in its current unfinished state It doesn't have an operator less than. Person has an operator less than, which we discussed in operator overloading, and you've just seen the code for. Bank account does not. If I try to do the same behavior with bank accounts as I've been doing with integers, strings, and persons, I don't get the kind of delightful error messages that I would like to get. I have to tell you, when you're working with templates, sometimes the error messages can be a little opaque. So here is some code that creates two bank accounts and tries to call the max of B1 and B2. Let's see what happens when I compile this. I'm just using the keystrokes to build it. So it failed, and the error is no operator found, which takes a left-hand type operand of type bank account. That's not bad. It's even telling me that the problem is here with the less than. But you'd be tempted to go and say, well, I'm not calling less than. I don't understand what the problem is. You kind of need to know that max uses less than, and that by calling max, you're trying to use less than, and you don't have one. You don't really get a good error message saying you don't implement the right stuff to use this template. The burden is all on you as the person who wants to use the template. In this case, a bank account developer who wants to use max needs to know what that imposes on bank account. By reading the documentation, if all else fails, maybe by reading the code and looking at it and saying, oh, I see it uses operator less than, or it uses operator plus, or it uses a member function called compare, or whatever it uses. And if for some reason you have neither documentation nor code, by getting error messages from the compiler. Bank account's not eligible to work with max. It just is missing the operators that it needs to work with max. And that's okay. You have to find another way to compare bank accounts, or you can write the operator that's missing for bank accounts. But understanding that nobody's going to check for you explicitly. You'll get errors, and eventually you'll figure out what causes the errors, but nobody's going to explicitly check whether a particular type is okay for use with a particular template or not. That's your. Let me summarize what you just saw in that demo. First, when you want to write a template function, you write it out with a placeholder standing in for all the different types that the function might be used with. So here's max, for example. You start template class T to indicate to everybody that this is a template and that T is a placeholder. And then you just use T as though it were a type throughout the function. In order to use it, generally the compiler will figure out what type you're using. So when you say max of 33 and 44, or of string 1 and string 2, or of person 1 and person 2, the compiler can work that out. There are times when it's ambiguous. Say, for example, you were to ask for the max of a floating point number and an integer. It could promote the integer to a floating point and use the floating point template, but it may not be able to figure that out on its own. And for other templates, it's not possible. You could go either way. So if you want, you can specify which specialization you want, like this. This says, I'd like the max of 33 and 2.0, and I specifically want you to use the double version of max. And that will, of course, for the case of max, which returns a T, mean that it will return a double. They're really awfully simple to use, and a person could use max without ever knowing it was a template. They could just believe that it had some magic ability to figure out the maximum of integers and strings and person objects, just maybe by understanding the meaning of the letters MAX standing for maximum. It's not how it is at all. It's a very simple template function. Now you know.